techniques. So first of all, the first important thing is that the text pre-processing section is actually one of the most important ones if you were to do the NLP correct, because as they say, the garbage in, garbage out, right? So if your data goes in that is not really gone through the appropriate data pre-processing, your final result will also be undesirable. The most important thing here to think about pre-processing is to prepare your NLP or your data set into a type or into a position where all the noises have been removed and some of the normalization of word happens, standardize of objects, and then conduct some form of parsing. So sometimes to parse something is basically in the terms of language, lexicon sort of language type of process in which you actually separate a sentence into its individual parts in terms of objects, subjects, all of these adjectives and so on. You separate them into their own parts. So these are the general steps that you need to go through first. The very beginning is to noise remove. Noise can include many things. A very obvious one is punctuation, right? Punctuation aids us in reading text and reading books. Imagine a book without any punctuation. How hard would it be hard to understand it, right? So to have punctuation give us meaning. So there are sort of some puns or there's a book called Panda Eats Panda Eats and Shoots, right? Something like that, or it's basically play on punctuation. Panda eats and panda comma eats and shoots, basically eats bamboos and shoots or something, and there's a part where you actually put it behind bamboo and it's like panda eats bamboo and then shoots. So shoots is like a smaller size, like young bamboo, right? They're called shoots. So depending on where you put the comma, you actually make it sound different. It means different things. So having punctuation is really important for us as people to know where certain context actually happens. For computer-wise, it's not so important in terms of where that punctuation is, because at the moment, NLP processing is much more targeted in terms of word meanings. So the important thing to do is to be able to sort of separate your sentence into individual words, and then basically just standardize some of those words. Sometimes several words may have one meaning. We will then narrow it down into one meaning, swap all of the individual different words into this one word, so you simplify your problems. And then first of all, you need to remove the punctuation. And in terms of punctuation, type of punctuation is right here, special symbols removal, that the computer does not see that as anything of use. And besides, when you have special characters such as this, sometimes in the processing of natural language processing, having punctuation or having all of these special characters adds a different levels of complexity of processing, right? Because you have to because different kind of symbols actually means different things, especially, for example, the @ sign here. @ sign, most of the times it means the part where it actually separates the username and the email provider, right? And sometimes @ sign in WhatsApp is to directly calling upon someone. Is like at this person, is like talking to this person directly. It has a certain meaning. And there's other ones such as hashtags. It starts with a sort of tag of a word that actually shows the topic and so on. So they actually have special meaning for us, but for computer, not so much most of the time. So that's why when you remove it, that is considered one of the noise removal steps. The second type of noise removal involves stop word removal. Sometimes when we talk and speak in a sentence, we have a lot of stop words. Stop words are words that is like a, the, of, on, all of these sort of words that actually is, especially the, a, and so on. These are words that actually is connecting other words that is of for more with more meaning. A is to indicate one or sort of we put it in front of a noun to indicate one or a situation or a type. The sometimes we put it in front of something to indicate a certain thing that we were talking about before. And is when we connect the two and so show some kind of connection between the two words. So when we remove the stop words, not only we remove some of the words that doesn't really have its own meaning, meaning that if we have words inside a text that doesn't really carry any specific meaning, we're essentially moving complexity from a word, from a paragraph that adds no value, right? We're removing things that has no value and does not contribute to the analysis. So removing that actually helps our future process. So that's why we remove stop words, and then we remove punctuations. These are the first two things we need to do to actually start the beginning part of text processing, pre-processing, which is noise removal. So after noise removal, we cannot just stop there because there are other parts of NLP or standardized things that may appear to be things that we could actually reduce, which is such as situations where we can actually see stemming of words. Stemming of words in the sense that some words that is supposedly love and loving and lovable, and these things are stemmed from the original word, such as love. And then and because of that, if we actually use this stemming, we can actually reduce three words into one single word, and that reduces the complexity even more. All these words of stemming, actually, if we do not do stemming, these three words will be seen as three different words. They would actually carry different meaning. They actually do have slightly different meaning, right? Like lovable means somebody or something is capable of being loved, and so on. And also the loving here is about the emotion of maybe somebody who is being loving, and so on. And love here is the word is the original word. There's other words such as lover, right? Lover and loving and lovable, lovely, such as those words. All of those words stems from the original word of love. And if we then swap all of these separate variations of the word with the original word of love, which is, I mean, if we were talking as in sort of human to human talking, and then we just basically say, you are so love, instead of you are so lovable, it just doesn't make sense, right? But for computers, it's not quite like that. For computers, it's like love is basically a sense of a feeling. Like, for example, when you look up a dictionary, love would actually come with a sort of meaning, right? It would have a definition. So if you think about it that way, then the word love actually can be a more general sense of having this emotion or feeling. And this emotional feeling would actually be, maybe it's towards somebody, maybe it's somebody else, somebody's feeling who is loving, feeling lovingly, and so on. So in that kind of a sense, it's a lot more easier to look at it when we use the stemming to actually reduce it down to one word. So that's why we use stemming. So imagine if you have a paragraph that has like 27 words, and have a couple of times when you have these kind of variations of word, and then you change it into one, and then maybe you can change it and reduce it down to maybe 20 words. And later on, you can then use lemmatization, which is another way of actually reducing even further, that it obtains the root word. So the root word is in linguistic kind of sense, the word itself doesn't really necessarily have to have the original look, as in sort of like in these stemming words, they all have the word love in some form, right? And that makes it a slightly different. So lemmatization looks for the root of the word, and by obtaining the root of word and then replacing that word by the root of word, you're actually reducing the complexity for even further. So all I can see is that, first of all, removing noise, removing the stop words, uh, removing stop words, and then removing the punctuation, and also stemming, and then lemmatization. Those are all the means, all the strategies of reducing the complexity of NLP later on, right? All of these are actually reducing them and making them a little bit more discrete, a little bit more sort of easily conveyable, not as complex as you would if you have all of these individual separate words to begin with. And then it comes down to, so nowadays that this part actually makes much more sense right now, is to basically use the object standardization to actually standardize certain acronyms or hashtags or URLs. Nowadays, within modern world, we have a lot of these new things that comes up, such as hashtags, right? Hashtags that was never around many years ago came up nowadays to indicate a certain topic, isn't it? So it's a topic related, and URLs are web page links that doesn't really make sense. How do you read a web page link? It's actually one link after one link, one after another one. So that is, they come in different kind of modes, and also they have different purposes. And to use object standardization is that you standardize a web page such as Google. So www.google.com, you just call it Google, right? And if you go to certain other ones, you'll probably have a much more different types of standardization and acronyms. You have sort of like was it IBM? There is the DHL. All of these are sort of acronyms of words that actually are together, but they make it into they use the first letter of every word and then make it into an acronym that people refer to and also know what they're referring to. But then if you just let computer know what is IEEE or IET, nobody knows what's going on. But because it's considered as a well-known abbreviation, then we could actually use some kind of dictionary. Remember, in Python, we have been able to create a dictionary, right? Create dictionaries is a data type that contains key and value pairs, remember? So key and value pairs, the key could be the IEEE, and the value could be, is it Institute of Electrical Electronics Engineers? So it's like the whole thing, isn't it? So it's a lookup table kind of way. So that is object standardization. You then, so replacing these words with equivalent standard would be called object standardization. Parsing. You have noticed nowadays when recently up to now, since this morning, that for NLP there are many words or many concepts that we never need to get in contact with or never even need to know until we get to NLP. NLP actually introduces a lot more new terms, right? The stemming, lemmatization, stop words. These things we never really consider until we reach NLP. Similarly, when we talk about parsing here, parsing is to basically separate your sentence, not just word by word, but entity to entity. It separates sections of what by its usage than you would just by individual words. So it's easy for us to separate a sentence into individual words, right? We go and do what? RE dot find all. Do you guys still remember regular expressions? Completely forgot. Nothing. I finished the class and then I went home and then that was it. Seriously, I was hoping that was not the case. Okay, so in regular expression, as I mentioned, I don't know if you still remember, is during the Python programming course, I mentioned that regular expression are usually used by people who does data cleaning, right? And data cleaning, and usually cleaning what? Words, right? So NLP naturally would actually involve some form of regular expression. So if you are somebody who is gonna be doing something in terms of NLP stuff, then it's a good idea to refresh your regular expression parts. If you don't have to, then good for you. Good for you. You don't have to do that. And when you only need to revise it when you come to use it. So syntactical parsing is a very traditional type of parsing. It parses. It actually, the word parse, you can just basically say, it's basically separating a sentence into sections. So to parse a sentence by syntactical parsing means that you're parsing the sentence by syntax or by grammar. By grammar means you have different sections. For example, I want to go to the zoo or something. Like I am the subject, right? I want to go to. I think go is verb and want to is an adverb, and then the zoo is the object, right? The place I want to go to so you separate a sentence in terms of that, and there's a huge sections of sort of field of study that people, I don't know if you know, there is such a sort of a subject group in university called linguistics, right? You could actually go into university and study linguistics, and the things that you're going to study is about how people put together sentences, right? How people talk and so on. And that's an entire section of field of study, and we're not going to go in that deep. So what we're going to do here is basically say we're separating a sentence based on its grammatical parts. Yeah. And by doing that, we have many ways of doing it. We can actually use a dependency tree, because in this case, what is the thing that is most important here is the I, right? I want to do something, or I want to go to the zoo, or so on. Or maybe go, it could be the central of your tree. It depends on how you see that sentence, which is the most important word. Or part of speech tagging. Part of speech tagging is that instead of putting them into a tree kind of form, we actually give each part a tag, a sort of a small, short, abbreviated tag of what it is. For example, subject, we use sub as a sort of a part of what it is. It tags it by a sort of a small abbreviated way of naming it. Next one, so syntactical parsing is something that is very linguistic based. Now we're going to talk about something is called entity parsing. This is probably something that we're probably easier to understand because it uses phrase detection. Phrase detection meaning that if you're looking at a sentence such as, I would like to watch Beauty and the Beast. And to us, watch Beauty and the Beast indicates that we're implying that this is a movie, right? Because we all know Beauty and the Beast is actually the name of a movie, right? And you can also consider Beauty and the Beast being a phrase. It's actually, if you put them together, it means something special other than if you actually separate them out, they mean completely different things, right? Because if you separate them out, it's basically Beauty and Beast. And if you take out the stop word, the and is gone. So what you're left is Beauty, Beast, right? And that means completely different things. So sometimes for certain NLP purposes, it's good that if you actually look for phrases. If you look for phrases, you are just like this. When you Google stuff, right? You Google stuff, sometimes you want to Google a phrase. What do? You put a inverted commas outside of that phrase, right? You put that, and then it will just look for that combination of words instead of looking at the individual words separately, right? And that makes your search a little bit more targeted, and you get to search, get to find whatever you need to find very quickly. So same thing as here, when you use phrase detection instead of just word detection, it makes your parsing a little bit more targeted, a little bit more with purpose. Topic modeling is instead of phrases, we use a topic as something that we want to detect. So how are you guys feeling about this? NLP, different, right? NLP is quite different from what we have done up to now, especially from day one and day two. Have you gone through day one and day two and started thinking about maybe data science is just that, ingesting information, put into data frame, and then look at the frequencies of things, and then df dot what info, and then maybe split, standardize, and then train, and then deploy. That's all, right? It's actually not all. That's actually only one section of it. And even with that, if you were to sort of learn more of it, you actually would actually go into every single model, every single technique, and then inside there, you get to choose much more refined ways of refined models that is more targeted to a certain purpose. So at the moment, you guys are given all those models are fairly generic, very generic of that type, even though different models have different purposes. Regression to predict, right? Classification to find two different types or three different types of things. Clustering is find demographics. And then these are the things that is very, very easy to understand, or maybe when you revise it, it'll be very easy to understand. Because I know for the 2 days, it's quite intense, right? Yeah. But I know before the exam, you guys can always make it because there's a revision before the exam, isn't it? Now, by the time when you do that, and then if you have done enough revision, by the time when you finish some parts of revision of that, you'll be thinking, the teacher said it's right. It's basically this is that, this is that. It's very simple. If you have looked at it for the first time, it may feel a little bit over your head because there's too many things going on. And only when you sort of distill it by your own knowledge, like when you do revision, you distill it to what you understand, it starts to become much more simple to you. So that is one of the ways to actually how can you tell whether if you have mastered or have learned your exam material is that if you can actually teach somebody what you've learned and that person understands, then you probably have a right at least 80%. If you sometimes you can actually practice on your friends, practice on your family members, like I'm going to teach you this and then you tell me whether if you understand or not. If they understand what you teach, then it's pretty good indication that you have learned and you have understood. But if you try to teach and then you teach and you're thinking, wait a second, I don't know if this is correct, I have to refer back, that means you're not there yet. Okay? All right. Syntactical parsing. Parsing in terms of dependency tree. I mentioned this parsing, syntactical parsing is basically you would have the root at the very top of your tree. So these trees are actually upside down trees. These are upside down trees where the root actually comes on top, right? The root is the word that is actually linking everything together. So in this case, it's actually is. The bear is in the cave, And the D here is the determinant of caves, meaning that this is indicating that we both know that which cave it is. So it's the cave. And then another way is basically by its syntax. So syntax, this is a sentence as overall syntax, as a sentence. And then you separate to nouns and you have verbs. Within the nouns, you have determinant, you have the noun itself. So the bear, and then the verb is, and then you have other sections right here, and then you also have a determinant and a noun, the cave. So this is also a way of actually do a dependency tree. You don't really need to sort of, have this part learned by heart. I just want you guys to have a feel of how and what it does. Because later on, when you guys are told, like, you need to do NLP stuff, you need to help me summarize this thing. At least when that happens, you know when you need to do parsing, you know what it does, right? So basically, this is what it does. Part of speech tagging, similar to that of the dependency tree, except it is basically set into these small abbreviated things. So the S is the subject, right? S, it's not here. S means the subject, and then the NP is the, which is NP? This is actually a short section of this part of speech tagging. You can actually search online. The tagging itself, the abbreviation of the tagging is quite universal. You can actually find them and then find out what do they stand for. And this part of speech tagging actually basically distills whatever these into small abbreviations. Instead of writing sentence, you actually write it into a tag, sort of a name kind of tag kind of thing. and then once you've done all of those text pre-processing part, we move on to text classification. So that means you can see up to now, since this morning up until now, what have we done? We just talked about text pre-processing, right? We haven't even got into the part of actually processing yet. We just did the preparation until now. That just shows you how important it is to do the text preparation before you go into NLP. So whenever somebody tells you, oh, we need you guys to come and do, oh, sorry, Adam, I did not see your chat. I just saw it. Stemming, what about unlike, dislike, like? Well, okay, here's the thing. When you have these unlike, dislike, these two things here, because it has this sort of like these sort of extra bits that hangs on top, as in un or dis or these kind of additional parts in front, it means the opposite of the thing, right? So they would not actually consider that as stemming. It would not consider it as the same thing. So that doesn't really consider as one type of word. Because in English language, I don't really know if it's quite universal, because I'm sure for other languages they have other things to indicate not something, right? So in English language, there's only a few things that you can actually add to a word to mean something different, or something like maybe something like accident prone. Prone means more likely to be in accident. Accident prone is sort of a phrase, but then you would actually, or accident averse. Averse means I would not want to be in accident. Somebody's always protecting themselves and finding all ways to be prepared, that I'm accident averse. I dislike, or I reject, or I prepare myself not to be in accidents. So having these extra words onto these one word would change the polarity of that word completely. And when you do stemming, that will usually not be considered as the same word. So that's not really a big problem, especially English. If you notice that NLP is a little bit biased, actually. NLP is much more pro-English. Because NLP, it's unlike mathematics, right? Mathematics is all universal. If you have an equation, no matter which language you're using, the equations will always be the same, right? But NLP is actually quite language, favored in a way. If you're using a language that's being used by majority of the people who are doing data science, I'm not just saying that majority of people, because if that's just majority of people, then Chinese will probably be quite high on the list. But in fact, it's not the case. The Chinese language NLP is not as extensive as some would say English are, because even some Chinese, we actually do NLP in English, right? It's because it just so happens that this language is the one that we use most of the times for official languages in the whole world. Chinese only use in a certain part of the world, and sometimes, especially in China, not everywhere is very sort of like tech savvy. Some places are quite rural and quite backwards, and they don't need to use NLP so much. So in that kind of a sense, especially when I talk about this, I'm also talking about Malay language. You guys notice that stop words, some of those words, Malay language sometimes are actually gets bumped up together with Indonesian language, right? Like sometimes when you have translations, when you have these things, instead of showing Malay, it will just say Indonesia, right? There's a difference between the two languages, isn't it? There's definitely differences between the two languages, but sometimes they will just choose that particular one because of this. Even though that is the case, but nowadays I think in the data science scene, NLP kind of aspect in Malaysia, there's one person who is really one local Malaysian who is really into doing NLP in Malaysia. I forgot his name. One friend actually showed me his work. It's actually quite extensive. He actually does a lot of NLP stuff in Malay language. Do you know how difficult it is to come up with a dictionary of the Malay language by himself? It's actually really quite a lot of work. You have to have a commitment to do that. It depends on how much people are exposed to it. So if you guys are more exposed to the Malay or for the NLP, then you use Malay language, then you can actually contribute to the data science NLP scene in Malaysia. Do something to contribute to the Malaysia NLP. That would actually be quite good, because think about it this way: if you do that, other people can use your stuff, and then they can actually process NLP stuff, and then things will become roles are much better, and things gets advanced much quicker. Think about it. Okay, so now that we've learned about the pre-processing, we're going to start doing things like, or see where can we apply these NLP techniques, especially in, we have talked a little bit about it, but we're going to look a bit further in this. Email spam identification. In the old days, the spam that we were sort of like scared of getting is that, what is it, the Nigerian prince email, right? I'm the Nigerian prince. I've got this much money locked up in a bank that I cannot get. Please send me this much money. I can then send it to you, and you can earn this much money. But nowadays, the email spam is so much more elaborate, and the way that it actually start to look very, very convincing, right? Some of them will mask itself as a sort of like a internet service provider, for example. Unify, sometimes it could be banks, it could be all these sort of things, places that you trust. And then they say, hey, you've got a parcel coming, we've got it sort of at the, the KLA hub, and it's being sort of locked up because you have to pay tax and stuff. So please pay the tax by sending us a CMB receipt to this account. Just random accounts, So these are spams that actually can cause really detrimental effects on your personal life. And sometimes spam is just basically the general spam, advertisement spam. Those are quite intrusive, yes. Dangerous, not so much. But we don't like them anyway. We don't really see this as a big deal nowadays, whereas like really long time ago, when the email thing starts to come out, the spam is actually a big deal because they all go into your inbox, isn't it? Nowadays, Google have the spam folder. So most of the times I don't even realize I've got spam until some days I have a lot of time on my hands. I just click on it. Oh my God, so many spam. So spam is no longer a big problem for us now because Google take care of it. Say if you have an internal email, then it does not route through Gmail, and then you are tasked with filtering your company's spam mail. What do you need to do? You need to start looking at what are considered spam mail, right? And then see how their texts are written. For example, this is a get rich quick deal, or this is some, for one time only, limited time. And then the email address is some really, really wonky, very strange looking email. And they will send to a very long list of email addresses. These are all signs of email spam, right? So email spam identification is from the wording, from the way that the title of the email actually comes in. So that is one of the ways you can use NLP to spot it. So if we do not use NLP to spot email spam, then most of the times we probably have to eyeball it ourselves, right? We get a whole email inbox of emails, and then we have to tick or untick ones we want to delete, isn't it? And God forbid if we take something that is from our boss and deleted it, that would be bad. So it's very important to know what you can do with NLP, and the potential is all out there. Potential, and also topic classification of news. If you are like me, who really likes to read news, I don't really know why I read news. I read news whenever I have time. There's stuff on my phone, and there's like this news and that, and then I have Twitter, and then I have Facebook, and then whenever there's some news, I will just read it, even though I may have read it somewhere else. One of the things I really wish that my Facebook can help me do is to classify those news by topic, so that I can just read one article for that topic, and I'll be done with. And none of those will come back out again. So any other news I read would be a new type of news instead of saying the same thing over and over again. Sentiment analysis, sentiment classification. the very simplistic way of talking about sentiment is to talk about somebody who's happy or sad, or happy or unhappy. So two things. If you're happy about the service, or are you unhappy about the service? So that is sometimes what organizations or industry want to figure out without having to pay for labor and get human resources to actually do them, because it's quite labor intensive, right? Imagine if you go and get hired as a job of complaint reader of every day. You go into work and you sit down, and immediately your inbox is swamped with all these complaint letters, and you have to sort them out every day. That would not be a desirable job, right? Immediately I'll be on LinkedIn and change my job. So sentiment classification nowadays, a lot of them are being done by computers, and they're usually to assess large quantity of text, such as paragraphs, surveys, reviews. Reviews can be restaurants or services or products, or sometimes in Shopee nowadays got reviews also, right? Shopee, Lazada, all of these have reviews. And sometimes, especially in Shopee, I've noticed nowadays on Shopee, when you buy stuff, they give you coins, virtual coins, to give a review, right? So if you give a review or rating, they give you some virtual coins, which actually doesn't really amount to much lah. So you can use that coin to play their games or so on. You can use it to maybe accumulate it to pay for as a discount for your own purchase in the future. So all of these things means that all of these commercial e-commerce or companies are going after they're very interested in you giving your opinion regarding a service. In the past, we never do that, right? We go into a shop, we buy something, we go home. The only way for a company to know whether if people likes it or not is whether if things get sold even more in the future, or just nobody comes anymore, right? But nowadays on Shopee, there's huge competitions of different people selling the same stuff. You notice you want to look for one thing, and there's like tens or like hundreds of different sellers actually selling the same stuff. And it's really up to you to choose the one that's the best. Maybe one that has most people sold, most people bought it, and also have high ratings, and the cheapest. So best if those three are all included. But most important thing, sometimes when I'm actually looking for a product, I actually do go to the review section. And then it's not such as the reviews that people give, because I think most of the times people just go there to say, I received it, it's very fast delivery, which doesn't really help the situation. I want to know how good the product is. The only thing the Shopee does best is that they give you pictures, right? People actually upload pictures of what you bought, what they bought. And that sort of gives you a sort of an insight whether if it's sort of good or not, isn't it? So in the future, things will become more like how Amazon does it. You guys know how Amazon, you guys been to Amazon's website? You won't be like that. Or have you not? Have you not looked at it? Have you not looked at it? So Amazon, okay, let's have a look since we're at it. So Amazon reviews. American people have a lot of things to say when they come to reviews. Read customer service reviews. So, okay, let me. Do you guys see? No, let me. Which one is it? This one. Okay, starting from the top. Okay, wait. You guys see it? You guys see it? So, you see, this is never gonna be the way Malaysians does reviews, right? Malaysians does reviews in a very sort of, like Twitter kind of way. 140 characters at most. But you get to know exactly what you meant, like this is terrible, doesn't work, or worked and then something broke. That's all I want to hear. See, Americans does it this way. All very, a lot of talking, a lot of talking. Some are not bad, but generally you can see there's a lot of text, isn't it? Oh my god, and some capital letters too. You know, when people write capital letters on the web means shouting, right? Yeah. So many. So imagine if you are somebody who is working for Amazon, have to see through or read reviews. This is not a good job. Especially for the ones that has 2 or less stars, right? Means this person has something that really does not like. And when that happens, you have to read it. I mean, it's bad enough you have to read one bad review. If you have to read it as a job, by the end of the day, I don't know how to go home. Oh, this world is not good. And that's why NLP comes because of this. I bet the first person who want to start using NLP or start like researching this had a summer job of reading horrible reviews for some company, because this is not a job that people should take up. It's definitely something that should be automated, right? Not so much as Shopee. Shopee, I think really the reviews are still very basic. Whereas Amazon, and then you have other websites that does, like any American websites, they sometimes have a lot of things to talk about. Really, really, I wouldn't say it's descriptive, but verbal diarrhea. A lot of things that wants to come out, but then they really don't go to the point. They should just say, I'm not happy about this because I did not get my product. You know, sometimes like on Shopee, you'll be like, I did not get my product, so I'm getting one star. That's all I need to hear. All right. So again, uh, so sentiment classification, and that's why sentiment classification here is not so much as, you know, I don't know how to feel, how a sort of a review feels to me, and I want computer to do it for me. It's mainly like, I know how people feel when I read stuff. I just don't want to read it. I don't want to do this. That's why I'm getting computers to do it for me. So computers does the sentiment analysis for you so that you don't have to. And finally, organization of web pages by search engine. You guys know that Google search are all text, right? They're basically, so imagine what they need to do is every single day there could be millions of new web pages that comes out, right? New web pages that appears online, for example, e-commerce, for example, somebody's blog space, somebody's new website, somebody's launching a new thing, and then they put it on the website, and computers such as a big organization such as Google will have to go and index it. They index it in such a way that they will put priorities of which page should go first and which page should go second, and so on. The way that they actually prioritize the ranking is based on, first of all, the click rates, right? The ones that's been clicked most within a given term, within given time, tend to go more in front. And sometimes in the beginning, this will happen, and then sometimes you will see those people who actually are trolls, right? They're trolls, and then they do things that generates lots of clicks, but then when you click into it, there's nothing. And then Google starts to become smart and says, I will only put things at the very top that is at least this duration long already, that this web page has been there for this long and it's been tested and trialed, that is a reliable website instead of a troll website. So the way that web pages actually organizes is also all very much NLP. So even if you don't do any NLP now, you can actually think about using NLP in the future, because in the future, for example, you can actually even do that for your own emails. For example, you every day, I don't know if you go into your office, first thing you do what? Check email, right? Check email sometimes, right? You check your email, sometimes you get 30 email, 50 emails, depends on, the situation. And sometimes it could be 3 or 4 emails from the same person that they really like to write emails. So what if you could actually get your computer or your NLP to go in and sort out things first? For example, you would actually sort out things that is sent to me directly and nobody else. That is basically means that this is actually more important to me lah. If it's a sort of like a corporate promotional email that actually sends to everyone, then you just put it as another category, right? So if you do that, then you only look at those few ones actually targeted at yourself, and then you can actually flag if this is from this person, which is your boss, then you read first. These kind of things will make your life so much easier, right? Isn't it? And usually I will depends on some days, it depends on whether if the email asks me to do a certain job or not, like a certain kind of thing that I have to look for. Sometimes to reply email takes me about an hour to reply all of the emails to before I can start any other jobs. Imagine if your computer can do this for you and you only probably need to spend like 15 minutes to do that. You save a lot of time. You don't have to do work for the rest of the time. You can just sit there and do other things, right? That would simplify your work so much more. So NLP is not just for people who are in search engine business, sentiment analysis business, or topic segmentation business. It's actually for everyone. You could actually do that to make your life easier. Some people say, well, if that's the case, how come I don't see many people use NLP? Well, one thing is that data science is actually quite becoming much more popular now, right? Data science was not popular some time ago, isn't it? NLP is going to be when data science become like everyday stuff, and that's when NLP will start to become much more mainstream. That is basically how things are trending. Tokenization, back of word, classifier evaluation. So now we move on to the part where we actually do some actual work. So tokenization is it's actually a part where you would actually tokenize. To tokenize, what is token? A token is what? A coin, right? Or something like that. To tokenize something is to separate a whole thing into different parts. So different parts. So this is a process of breaking a stream of text into words. It's called tokenization. Words, phrases, symbols, and other meaningful elements called tokens. And this changing them into tokens is called tokenization. To tokenize something is to separate them into different words, phrases, or symbols. And when you have a sentence, do you guys still remember? I know you probably don't remember in Python programming. There is a part where we do ru.split and split by space, right? And that is literally a one type of way of doing tokenization. You tokenize a sentence into separate words. Separating sentence from text using punctuation, separating words from sentence using space as delimiter. We've done this before. So by the time when you learn Python programming, you're already somewhat into NLP already. So this is a test that isn't so simple, 1.2. This is a test that is not so simple, and then 1.2. So surprisingly, this 1.2 here is considered one word, right? Usually when you separate by the dot right here, the dot is actually considered not so much one word. So bag of word model. Imagine if you have a whole paragraph of words. You've done tokenization already. You've done tokenization to do what? To separate those sentences into words, right? What do you do next? What do you do with a bunch of words? Just separated words, no punctuation, no stop words, and then some words have already been becoming their very simplistic self, like love, loving, all to one word. And now you separate them into individual words. So all you have now is many, many words separately, right? What do you think is going to happen next? What is the end goal? The end goal here for perhaps for sentiment analysis is so that I can actually maybe see if each of these words of what kind of sentiment and then add them together, right? I need to come up with a collection of words, right? I need to sort of make sense of those words. For example, some words inside all of these may have duplicates, right? For example, if we're doing some stuff like we're going to the sea and then I'm gonna eat some fresh fish from the sea. So the word sea happens twice. You don't want it to happen twice, right? You just need to have once, because duplicate words just basically adds no work that you don't really need to expect. So the bag of word model is that you take all of these individual words, and what you do is you take all of the unique words, put it into a bag. That's for one paragraph. Imagine if you have 3 paragraphs, right? 3 paragraphs. 3 paragraphs becoming tokenized means 3 paragraphs of individual words, right? This one, unique words into this bag. This one, unique words also in the same bag. Third one, unique words also in the same bag. Now you have a whole bag of many words, right? And a whole bag of unique words, isn't it? So can you imagine this? A bag really is a bag of words, a bag of unique words. And now that you have this bag, just imagine this bag is inside the bag. It's not a sort of because whenever we think about a bag, things that gets into the bag gets all messed up, right? Because it's not really sorted. So imagine this bag, the bag of word, this bag, actually in the bag there's only one Excel sheet. In the bag there's just one Excel sheet, and the top row, right? The top row are all of the individual unique words. Can you imagine this? One Excel sheet, top row, all unique words. And then what do we do next? Okay, now I have 3 paragraphs of words, right? So for the first paragraph here, all the unique words, when this word appeared in the bag of word, I'm going to put a 1 for that. So every single row that's after the first top row, I'm going to assign it to 1 paragraph. So the first paragraph, I'm going to have maybe this paragraph, I'm going to, the word see, there's one word that's see, I'm going to put a 1. And then the next one is fresh, because fresh, what did I say? Fresh fish from the sea, right? Fresh, I forgot. So, sea, yes, there is a word see inside this paragraph. Fresh, okay, another one for the same row, and then fish, also 1. So then the next paragraph would be the next row. And then the next paragraph will have different sets of words, right? So each of these columns would actually be 1 word, right? For this row here, when these words appear, see, there's a word that is the same word. Here, we'll put a 1, like that. And you will have a whole bag of word that is with an Excel sheet of the top row, which is all the words you have, and then many rows. And these rows, each row indicates a paragraph or a document. So that is why it's called a bag of word. It contains all the words that you are encountered that for different documents. Then what do? Okay, if you were to want to find similarities of these paragraphs, for example, this paragraph 1 and paragraph 3 actually very similar. How do I know they're similar? Well, because these unique words actually appear. There's a 1 here, there's a 1 here, right? 1 here, 1 here. So when you see a word that has a 1, paragraph 3 also have a 1. So there's a lot of similarities in terms of the words, right? That's how you find similarities between two paragraphs. And that's how the bag of word actually works. I hope you guys can sort of visualize that. If you cannot visualize, I can show you this. So just now so this right here is the Excel sheet in the side. So remember the Excel sheet, I said the top row is the words, right? So here is the first column is the words. And then document 1 is this document. So for this document, I'm going to take away all the stop words, the punctuation, after I do stemming, after I take away the and stuff, and then I change them into individual words. Then I'll just say, in here I have the word quick. Quick is where? Quick is here. And for document 1, I put a 1 here because it is in document 1, right? So that is how you actually formulate the bag of word based on documents. Obviously, if you are working for Google, your document won't just be 2 documents, right? Your documents will be a few billion web pages. Good thing we're not doing this job. So by that time, sometimes Google's, so that's how, have you guys been to a website? It's like change sort of website that gives you an alert when another website actually have any changes, right? So sometimes, like for example, sometimes when you're really interested in buying tickets for an event. Like for example, there's a Ticketmaster website and there's new concerts coming out, but you don't know when the tickets are coming out for all those new concerts, right? And sometimes these concert tickets get sold out really, really quickly. What do? Go to another website that gives you an email alert whenever there is web page change. Web page have any kind of alert changes, they give you an alert, so you don't have to go and check it all the time. And what do? They basically just do all of these things whenever an element actually makes any changes. Imagine if you're just looking by the words, then for the bag of words, if the words actually change, right? There's addition words or there's less words, there has been a change, right? That could be used for another way of using a bag of word model. But generally, it's how when they look at a website, it's actually looking at the meta character, metadata at the back of the HTML, if there's any changes. But let's just presume that it's actually documents, and that's how you would actually look at it. Now that you have the bag of word model, we have sorted. So the bag of word model is basically sorting out your documents by word, right? You're adding unique words to your bag of words, and then you're gonna give like a 1 for that column of that document, and then to indicate that this word is there. And then once you do that, just now I mentioned, if just so happens that document 1 and document 2 to be very similar documents, means that their texts are very, very similar. What's going to happen is that whenever you see a 1 in one of the documents, the other document will also most likely have a 1, right? So that shows that these 2 documents are very similar. So how do we do that if we were to do that using a formula instead of just looking at it ourselves? Because sometimes a paragraph can be really long, and this bag of word model can be really, really long, isn't it? I don't really want to go in there and count it every time. So what I do, I use a text matching purpose here by using a certain thing called a Levenstein distance. Levenstein distance is very particular use in NLP because it looks for similarities of paragraphs to another paragraph by talking about the minimum numbers of changes. So if you have 2 paragraphs that has only 1 word that's different, means that these 2 documents are very similar, right? If you have just 1 word different, to change this document into exactly this document, you just need to change this 1 word, right? Just need to change 1 word, and it completely, revamps itself as the first document. So that is what Levenstein distance means, is that minimum number of edits needed to transform 1 string. Obviously, a string can be really long, and string can be a whole paragraph. 1 string into another string. So that's when you actually look for 2 things. How close are 2 documents is by how many steps do you need to change to transform this into exactly this. So that's how you actually find similarity. So if we compare this paragraph to this paragraph, it takes 10 changes, and then this paragraph to this paragraph to this paragraph, it takes only 5 changes. Then this and this is much more similar, right? You guys still with me? I've got a feeling that NLP I know that NLP is a little bit distant in terms of concept. I think most of the times we can use our intuition and the way we talk or the way we actually use words to understand some of the stuff. But there are concepts in NLP that is a bit out there, right? It's a bit, I didn't know this was going to be the case, but apparently it works, then that is basically how NLP works, is because it's something that we learn ever since we're born, right? We learn about talking since we were born. We take it for granted. But when you actually learn it as a subject, it has to be taken in a bit different ways of learning. So that's why obviously when we read two paragraphs, we can tell whether if one is more similar than the other one, right? We can just tell. We don't really need to count how many letters need to change. But if it's computer doesn't have the intuition we have, so they have to come up with all of these techniques to be able to spot it. And then there's other one, it's called phonetic matching. Phonetic matching is quite funny. It's almost like, have you guys had those rhymes when you're little? Like those kind of, not quite poem like lah, they're like rhymes that when you say something and then the same kind of phonetics come along and then you change one word at the end, right? That is sort of like phonetic matching uses the way, like for example, loving, lovingly, the words, the way that you talk is very similar one for another. In a way, this can be considered as phonetic close. The way that we talk is quite close. But personally, I think the one that's been used most in NLP to detect similarity is either Levenshtein distance or cosine similarity. Cosine similarity, have I mentioned cosine similarity before? Oh, okay. So you guys know cosine, right? Still remember cosine? Oh, I'm sure you do. Cosine is a right angle thing, right? Do you still remember? Theta? This is y, and then this is x, and then this is r, right? So cosine theta is equal to, obviously divided by r. Is it x or y? Oh, 50-50. We could go either way. Okay, let me tell you. It's the x, cosine is the x over r. And then obviously if cosine is x over r, sine is what? Y over r, right? And so let's say this cosine similarity is not just the similarity in terms of if this one is equal length as the other one. The cosine actually has a direction. Whenever we actually do vectors, right? I don't know if you guys still remember vectors. In terms of vectors, there's two things. Imagine this is one text. This is another text. And you calculate this one, and you're trying to find out the theta, this angle right here, the angle that is in between the two lines, two vectors. So when this theta is approaching 0, means that this one becomes very, very short, very, very close to the bottom line. Means that this angle very small. Then your x and the r are virtually the same, right? Virtually the same kind of distance. So that is when this one is going to very closely resemble a 1, isn't it? So when cosine similarity indicates when the cosine value between two vectors is closer, the more closer it is to 1, the more closer they actually are. Imagine if you use sine. Sine is the more 0 it becomes, the more it becomes. So it doesn't make sense. It's much easier if you have something becomes 1 to be the good thing, right? So the more cosine is approaching the value of 1, the more closer the two vectors are actually closer to one another. So that is cosine similarity. Imagining mode turned on. Yes. Couldn't see two vectors. Okay, wait. That is a thing, isn't it? This is a problem with having another room. Let me use pen. So I'm terrible at drawing. Okay, so imagine this is your theta. You guys can see, right? Okay, imagine this is a straight line. Straight line, and then this is your x, and this is your r, right? And then the cosine is basically x over r. And imagine your angle starts to reduce. imagine this angle here now becomes like this. Theta becomes like this. And then later on, that means if these two vectors are much more similar than this one and this one, right? Because the angle, obviously the size of x and r is not the same. The r actually changes. Actually, the r, when it goes down, the r actually reduces in size, right? This is r prime. So r is actually larger than r prime. And r prime, the more closer it is to x, because don't forget, we always have to get this right angle, right? There's this right angle thing in trigonometry. Another thing I want to mention, you guys know data science, we cannot avoid mathematics in data science, right? I do have to say, even though anybody can learn data science, but it definitely helps if your math is strong. Definitely helps. Because when your math is strong, you can imagine stuff, right? When there's an equation, there's a lot of sort of abstract imagination and it makes sense to you. Like, for example, I am only middle in terms of mathematics, not the strongest. I've got friends who is like 100%. Yeah, I imagine they will be much better than me. But if you are if your background is more humanities than science, you're going to have to work much harder. It's just a fact. Because we're in data science, right? Data science is basically using mathematics to come up with a pattern to predict some stuff, right? You can't really avoid math. Maybe NLP you can avoid some math, but still at some point you can this vector stuff happens for NLP also, right? So if your idea, for example, if you come into data science and think, I'm going to find a way of learning data science without having to learn mathematics, please don't do that. Have the sentiment, have the mental preparation of being open-minded, like, even though my math is not so good, or math was good in high school or college, but then I forgot about it, just have a bit of a commitment of, I'm going to learn back my math, or I'm going to brush up on my math a bit more, because when you accept that and learn a bit more, you'll find that your data science game is going to improve greatly. It helps. Just a thought. Because every so often I always get participants sort of, whenever I mention something math, right, immediately the attention goes to the floor. I understand it, because if I have not been in touch with my college stuff, I don't really want to go back. And some more, I remember how difficult it is to revise for exams in the undergraduate or graduate times. I don't want to revisit that. But if you are somebody who are interested into data science and you find it something to be quite interesting, then I strongly suggest you to have a bit of an open mind to try to learn more of maths. Or at least have an open mind to actually revisit some parts of it, because you cannot avoid mathematics. It's just how it is. Maybe in the future, when data science becomes very modular, like a Lego building kind of stuff, then everything is a given, then maybe you can avoid it a bit. But then you're at the mercy of people who makes those Lego blocks, right? You can't really modify those Lego blocks. Whatever is there, you need to use them. You can't do customization. All right, so the more this line is closer to the next, meaning that the more similar one vector it is to the next, the angle here is becoming much more smaller. So eventually, this theta is going to approach 0. So cosine 0, theta equals to 0, is in fact 1, right? So that's why when cosine of that theta is 1, it means that the two vectors are generally in the same direction, because cosine is only the angle, has to do with the angle. It doesn't really talk about how long the distance one is to the other. So you can have one vector like that, and you can have the second vector like this. One is much longer than the other one, right? But they're in the same direction. and that gives you the cosine as in cosine 0, and you get a 1. So that is cosine similarity. And then in the future, there's Pearson similarity, there's Jacquard similarity. All of these similarities all come with the equation, right? Yes. I mean, the thing is, it's sometimes I read those research papers, and in those research papers, some really easy concept, they just really like to put in those equations that's complex to showcase that, oh, you know, I know my stuff, and I'm gonna put something really complex there. But in fact, if you do something like what I just did by illustration, a lot of these things can be explained very simply, and math is actually, the gist of it is actually quite easy, right? Now, is it time for break it? No, okay. Are you guys still, because I'm feeling a bit quiet down there. Are you guys still following okay, but very quiet as well. Okay, 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 very somber. Right. Okay. Where was I? Pointer. Okay. Think arrow options. All right. Next one. Libraries that you're going to be using for NLP. There are in Python, Anaconda, you should be able to find many of these libraries. The one that is being used by most people is called the NLTK. It's one of the most oldest, one of the most established packages for Python in Anaconda or in any kind of development environment for NLP development. It's called NLTK, Natural Language Toolkit. And then scikit-learn, you guys know scikit-learn, right? From day 1 and day 2. They also have some NLP parts in it, not as extensive, sometimes people say, but, and also there's this thing called GenSim. GenSim sometimes is used for topic modeling, which is topic segmentation, and sometimes you use that to find similarities between two texts as well. You can use GenSim as well. Text blob here is basically another one here is basically easy to use NLP tools as an API kind of form. So all of these are toolkits or toolboxes that you can use using Python to do natural language processing. Okay, sentiment analysis. How about I give you a bit of break now because we are moving from one topic to another. Right now is 3:15. Can we be back here maybe in 15 minutes? Not too long, we want to be here so that the quicker we start, the quicker we can go home, right? Yes. I get the most enthusiastic yeses when I say can go home early. This means something. All right, okay, don't waste time. Have a bit of walkabout.